Hi, I'm Karen Hemsworth. I use she, her pronouns. I work in the Faculty of Engineering, and this is the Industrial Engineering session for the AU Open House. I just wanted to do a quick land acknowledgement. So while we're in a virtual setting, the Dalhousie sits on the ancestral and unceded territory of the Mi'kmaq people. We're all treaty people. So I'm going to hand this over to Dr. Cyrus, who's the head of that department, and he's going to take it away from here. Thank you very much.
Hello, good afternoon, and welcome to the Industrial Engineering session. We are going to start with the video, and then we'll get to the live portion.
Industrial engineering is all about optimizing processes and systems, possibly by finding different ways to save money or resources or time or any other factors.
I guess in a nutshell, industrial engineering is making things more efficient. Industrial engineering is looking at things from the bigger picture with both a technical and human factors perspective to ensure that you can improve things as much as possible.
To me, industrial engineering is combining the engineering world with the business world. So we work almost as translators between engineers and business professionals to explain to them what's happening in a system and what they might do to improve it so that they can save money and just make things better.
At Canada Post, where I'm doing my co-op, a lot of it is working with the employees on the plant floor too, to make sure they're happy if you implement any changes, and working with them to make sure you hear their opinions too. So that's definitely very important too.
At the Halifax Port Authority, and I think my favorite part was, I guess I really like the whole sort of everything, but I think the best part of that was understanding, number one, how the port fit into the supply chain in a local, regional, sort of national and international context?
I think probably problem solving and critical thinking skills would be very helpful. And if you're creative too.
Going and trying to challenge yourself to find different ways to like solve things. I think those two things, communication and teamwork, are really like the most important things I think that I can take to the workplace after Dalhousie.
Well, that's a good question. So although a lot of the work that industrial engineers do is sort of in person and on the floor and doing a lot of communication and, you know, verbally and in technical writing.
We don't always have like a physical product that we're producing. We're not making like a robot, or we're not making, you know, a new drug or something like that. We don't have something that we're making that's physical most of the time. Most of the time what we're doing is we're improving what's already existing. And so I think that's really what sets us apart, is we don't have a physical thing coming out the other end. We have more of a theoretical solution, and we just work with a lot more business people than other engineers do.
I think industrial engineering does a really good job of creating well-rounded students who have skills that are directly applicable to co-op and sort of future job opportunities. So those skills that I mentioned before, such as programming, a lot of mathematics, statistics, but also sort of Lean Six Sigma, process analysis, and sort of those risk management, project management courses as well, really play a key role in the industrial engineering field.
Okay, so to begin with today, so we are going to have a number of people presenting to you today. So I'll just move over to our slideshow. So I just want to introduce various views. So I'm Pemberton Cyrus. I'm the department head. And my area of research is vehicle routing and scheduling, and also my teaching is in vehicle routing and scheduling. I just want to introduce some of the other people here. So Luke, Assad, Ode, Yosef, Scott, and El Reza on screen here. And so just invite everybody to just quickly introduce themselves. So Luke. Yeah, Luke, go ahead.
Okay, hi everyone. I'm going to be talking to you first about what IE or industrial engineering is. Sorry, there's just introductions. I'm in fourth year. I came up through Acadia. That was my associated university. Now I'm enjoying Halifax and industrial engineering at Dalhousie.
Okay, thanks, Luke. Asad?
Hey folks, my name is Asad Masood and I'm an international student at Dalhousie in my fourth year.
Okay, great. Good day, Dr. Venkatadri. Yeah, you're muted.
Hi, everybody. I really do hope that, you'll have a nice AU day here. We're passionate about industrial engineering, and I'm a professor here, work in supply chain, and we'll also talk about supply chain sustainability later on. But I've been here 21 years, and it's really a great place to study, to work, to do research and teach, etc., etc.
Okay, thank you. Yusuf?
Hi, my name is Yusuf. I'm a fourth year industrial engineering student at DAL. Today I'll be discussing some of the different impacts industrial engineers have in industry.
Okay, thank you. Scott, Dr. Fleming?
Hi, everybody. Yes, I'm an instructor, a senior instructor here. So my focus is teaching. I just completed my PhD, pretty much completed, in engineering design. So just thinking about best practices and how do we design things or how do we solve problems creatively. And my interest is in how do you figure out what the real problem is. So that comes through in some of my design courses that I teach, but I also teach things like data analytics and things like that. So good to meet you all, and hope you enjoy. This is like Dr. Venkatadri said, great place to. I studied here first, and then I came back and worked here, and it's a very, very positive environment.
Yeah, thank you. And Dr. Gassami.
Hi, everybody. Welcome to the session. My name is Ali Reza Wassemi. I'm the undergraduate coordinator of the department, and I've been with Dalhousie for about 11 years now. As everybody said, it's a great place, the industrial engineering specifically. My research area and my interest is in stochastic modeling, and pretty much that's what I teach, and also other courses in industrial engineering. So I will be today talking about some regulation and requirement for the industrial engineering. Thank you, Dr. Cyrus.
Okay, thank you. So we'll start now with an idea of what is industrial engineering. So Luke is going to start us off with this.
All right, great. Industrial engineering is about improving things. It's been said that engineers make things and industrial engineers make things better. Efficiency for processes, a problem sort of with a systems approach, and that can be used to consult or work in various sectors. Anything that works, we will make it work better. That could involve money, people, equipment, or facilities. Our main aim is just getting systems of things working well together. So it involves specialized knowledge. Although we can work anywhere, we're working in these various places with specialized skills that just happen to be very transferable. Industrial and systems engineering is concerned with the design, improvement, and installation of integrated systems of people, materials, information, equipment, and energy. It draws upon specialized knowledge and skills in the mathematical, physical, and social sciences together with the principles and methods of engineering analysis and design to specify, predict, and evaluate the results to be obtained from such.
So let's look again, talk about what's unique about IE.
Industrial engineering is a combination of technical and people skills. Oftentimes, you often have to roll up your sleeves and see a process firsthand and talk to frontline workers or staff to really understand what's going on. So you'll be meeting a lot of people. In the work world, you can work in healthcare, finance, airports, railways, manufacturing, you name it, anywhere that there's a process in the work world, there will be an industrial engineer.
Okay, thanks, Luke. So we'll go to Asad, and who will talk to us about the connection between industrial engineering and management and business.
Hey, folks. So industrial engineering is a term which was formed probably around 100 years ago. And industrial engineering mainly focuses on the improvement of manufacturing and industry-related processes. So with those processes and those improvements, any organization can benefit from it, and hence a business can profit. So the continuous side, improvement side of things allows an industrial engineering student to use their experiences and their vast practices to further enhance processes of any kind. So let's take an example. I'm an engineer working at the head office of ABC company, and my boss comes up to me and asks me to work on a project to enhance or further drive up the revenues because they have not been meeting up their targets. So what would I, as an industrial engineering engineer, do? My first step would be to analyze the data and find out the pain points within the target itself or the revenues, or just try to understand see where those where are we making those losses and why not are we making those profits. And once I analyze that data, I will go ahead and devise a plan and just go like, all right, these are a few of the things that we have to eliminate in order to drive up the revenue and hence be more profitable. Now, moving on to the next slide, let's talk about the management side of things. So we mainly focus on the application of engineering methods to improve manufacturing, right? So industrial engineering is a stream which relates to the management of industrial processes at a plant. So for instance, when you're developing and implementing a system, it involves the use or the effort of many other human beings and resources. And as a result, you as the industrial engineer has to manage those resources and the people that you're working with. So you would be working with a team. Now, in this major, the industrial engineering major, a student will learn how to efficiently manage and optimize the utilization of resources available, as well as learn how to use mathematics and statistics to utilize all of the resources that you would have in the future with the business that you would be working with. So our courses also allow us to understand the management side of things. In your final year, you will be given a course to learn about how what are the ways that you have to manage a team. And at the same time, you will again be working with a lot of teams with different projects. So you'll be understanding as to how the minds of different people around you work and how you can get the whole team together to work towards a common goal. Thank you.
Yeah, thank you, Asad. We move on to Dr. Venkatadri, who will be talking to you about the impacts of industrial engineering on society and on sustainability. You're muted.
Thank you. So, I wanted to say that industrial engineering, we talk a lot about sustainability these days, and we are front and central within the sustainability story. So just to, give an idea, resource optimization is central to achieving the UN goals for a sustainable planet. That includes land, air, and water. So how do industrial engineers get involved here, right? So what I want to say is that if you're really passionate about sustainability, think about industrial engineering. So some of the examples we were able to these are personal examples, optimizing the automotive supply chain using a new concept called the physical internet. This makes the planet more sustainable. Okay, optimization based decision making for natural gas at Emera energy. So this was a project that we looked at with the local company Emera. And as you can imagine, natural gas is more sustainable than burning coal, right? It's cleaner and so on. It doesn't go all the way to renewables, but it is a step in the right direction. So, we worked on this project here. And the other project that we worked on was, routing recyclable products in Nova Scotia. So stuff that you find in that you leave in the blue bag. So we developed, routing strategies so that large trucks could go and, from Efficiency Nova Scotia, could go and pick them up province-wide and then take them to their depots for further processing. So maybe I'll show you some slides here. So as you can see in the Mexican case, there's suppliers and there's plants. And what really we came up with is a new physical internet system, which or the physical internet system helps, reduce this travel in the supply chain. So it reduces fuel costs, and it promotes sustainable planet, just because you're burning less fuel and you're more optimal in how you pick up things and pack things and move things. Next slide, maybe. And here's the Emera project that we did. Most of you may or may not realize that the northeastern United States and eastern Canada and so on have a very large gas pipeline network. And moving gas through this network was what we did with a local partner, Emera Energy. And we optimized, some of their well decision-making processes. So when do you fill a well? When do you empty it? When do you move? Those kinds of things. And again, as I said, this contributes to sustainability because natural gas is a much cleaner burning fuel than coal. So it's got less particulate matter and so on. It does create greenhouse gases, but it is more efficient. So it's a step in the right direction. Next slide, maybe, Pemberton. And this was really our project with Efficiency Nova Scotia. You might have seen the big compaction trucks that go from Enviro depots. So what we did is we built routes for Enviro depots, so that the trucks could come in and move everything to Truro, close to Truro, at the Colchester bale fill facility, and that's where the subsequent processing. Again, you want to burn less diesel, and we looked at all kinds of things. In fact, my graduate student even looked at slopes and things like that, right? So that you can optimize how you move these trucks around. Yeah, I think that's it for me. Thank you. This is my part two, how lean engineering and Six Sigma can change. You've all heard of lean engineering, operational excellence, Six Sigma. This is, really core to industrial engineering. This is kind of the first level of involvement that we have. And we are experts in Kaizen, Six Sigma, lean, continuous improvement, process improvement, and so on. So why is this important? It's important not only for business processes. These are processes that happen on the computer, but also to physical processes such as manufacturing processes, transportation, and so on. So you got two kinds of processes, some that occur in the virtual world and some in the real world. And you want to be efficient in both. Okay, so industrial engineering looks at both. In fact, the Institute of Industrial and Systems Engineers has a division for information systems, which deals with the business process aspects and the virtual processes. What this does is, if you do this well, what we do as industrial engineers is improve quality, reduce waste, And, by doing both and make things more efficient, which was in the first definition. So you want to be efficient, you want to be, you want to take care of quality, and you want to reduce waste. I did 3 projects on this. So instead of reading these, maybe we'll go to the next slide. So as you can see here, these ambulances, they're made here in Nova Scotia. Who knew that, right? So what we did is worked on production and materials planning at TriStar Industries, which is in Yarmouth. And this is the only facilities that makes all the ambulances, fire emergency, emergency and first responder vehicles and so on. They make a whole variety of vehicles and different classes of ambulance and so on, and patient transfer units. But this is where it all gets made. And we looked at how you could efficiently plan for production and materials. Okay, so that's part of lean engineering that industrial engineers do. So this is talking about real impact because it saves people's lives. And question is, how do we do it in a cost-efficient manner? Next slide, maybe, Pemberton. Yeah, so recently I'm still working on this project, almost finished here. We looked at a company called Fairechild, which makes rainwear for children, also for adults a little bit. And these are very sustainable. So what you can do here is, the product comes from bottles and so on. It's completely recycled. And you have another use for this. But when the product is used, it's fashion product. It can go back and you can either use it in bottles, or you can come back and use it again for new stuff. So environmentally friendly, and yet it's got this chic element. So what we did here is looked at cutting and made the cutting process more. You cut fabric to make these garments. So we made that more efficient, and we also looked at some of the business process optimization. We looked at their business processes and made them more efficient. And the last one, we did business process improvement at, I don't know, some of you might know this, but there is a company called Clinical Logistics in town. They just got acquired. So what they do is when a large pharmaceutical company, let's say Merck, is doing clinical trials, then right outside, from their control rooms in Burnside, they manage all the logistics for those trials. Getting the patients, enrolling the patients, making sure that the patients get the right, medicines or injections or whatever, and then they take samples from the patients. The samples are then they don't actually test them, but they do this. They fly the samples to labs and then get them tested, and then the data gets collected. So the reach from Burnside, some of the clients are enrolled in China, in the Philippines, in Australia, all kinds of places you couldn't even imagine. And so this is a logistics company, and the reason why they exist is because they don't want Merck to do all these activities, because then that would be judge, jury, and executioner. And there is a little bit of concern that they might influence the outcome of the trials. So you always want to get the logistics done by a third party, and some of the testing is also done by all the testing is done by a third party. That's it for me. So a lot of exciting projects right here, Halifax, Dartmouth, Yarmouth, and we're at the center of good stuff, exciting stuff, cutting edge stuff. Thank you.
Okay, thank you, Ode. And so next we move to Yusuf, who will talk to us about the industrial relevance of industrial engineering.
So there's a common misconception that the word industrial and industrial engineering only refers to manufacturing. That's actually incorrect, because as industrial engineering students, we develop very diverse skill sets. So that's like programming, data analysis, engineering, economics, inventory management, and other stuff. And this prepares us to face various challenges in different industries. So some of the areas we might be involved in are healthcare, transport, construction, aerospace, and other areas in the industries. Next slide, please. So in a sea of industrial engineers, what's going to set you apart is the following. So you need to be willing to study and learn the system or process you're improving. So that's through observations, like visual observations, gathering data from people who work on the process, like completing time studies, things like that. And your ability to clearly and accurately communicate with clients and colleagues. So you can be in a consulting situation where you have a client that needs to speed up a certain process or reduce costs in a certain process, and you as an industrial engineer need to be able to communicate the changes required to your client. And you also need to be creative in implementing emerging technologies that reshape processes in various industries. So that basically means just having an eye out for emerging trends in technology and seeing where you can just integrate that into a process flow or a manufacturing process or whatever process you're studying or working on to just make it smoother. Next slide, please. So this is my first example in this healthcare. So industrial engineers can optimize supply chains so hospitals can get rapid equipment procurement services. So whether it's personal protective equipment or medical instruments and devices, industrial engineers can work to make that acquisition of items faster. And industrial engineers can also work on things like improving the blood collection, transport, and storage services. And we can also analyze process data and flows within a hospital or a healthcare environment. So we can design and enhance facilities that's focused on customers and patients. And we can determine optimal staff allocations. So that's pretty much how many doctors we're going to have at any given time, or how many nurses we're going to have treating patients, things like that. And our whole goal in that area is to just like decrease patient wait times and improve overall patient outcomes. So these are just a few examples in healthcare. Next slide, please. As Dr. Uday said, IEs really focus on just positive environmental change. So because we focus on waste elimination, this leads to like reduced process-specific energy use and minimizing the amount of wasted resources or unused raw materials within a manufacturing process. So some relevant systems can be transport. For example, we can optimize a delivery routing so it takes the shortest path that passes by the most customers or people being served. So that would essentially cut carbon emissions. We can work on material handling systems that are optimized to just travel the exact amount of distance required. So that means energy, like we're saving energy. Smart grid optimization, that just means that in the future, once we're more reliant on solar energy and other sources of clean or renewable energy, we can optimize that so it's flowing like in all the right places and not being wasted pretty much. And waste management is actually similar to the next point I'm going to make in the next slide, please, which is optimizing social services. So as industrial engineers, we can work with local governments and institutions. So that means we can enhance existing infrastructures and systems like educational systems, transport systems, and waste management systems. So we can apply systemic analysis through just looking at the process data and integrate positive changes by designing improved facilities and improving process capability. Improving process capability just means like making sure that we have a certain target and we've improved it. So if it's the overall wait times, we can see what we can do to reduce that, or like manufacturing times, we can see how we can reduce that and use as little resources as possible. And our whole aim is to integrate new technologies and concepts to improve pre-existing processes. So that can be digitizing current systems to reduce human errors as well. That's all. Thank you.
Okay, thank you, Yusuf. Next, we go to Scott, who will be telling us about emerging technologies in industrial engineering.
Thanks, Pemberton. In a way, I'm not as well suited to talk about emerging as maybe Uday or maybe anyone else in the department in certain ways, because I'm usually obsessed with understanding the most simplest tools. but in a way, we see, I guess it's all related. It all comes back to the simplest tools, and I really liked how everybody so far talked about all the different things that we can do in IE, and that's what I love about it, and that's what many of us love about it. It's just the various, you can transit, the routing of the transit, but even when Dr. Venkataji talked about, the producing the ambulances in the first place, not just routing them. So there's so many things we can do. So what I want to sort of talk about is a couple of things that I poked around, and I think some big things coming around are, I guess, everybody's heard tell of, or Internet of Things, which is a funny title because I find it's very it's confusing. It's not a good label for it. So the Internet of Things are basically things that have the ability to transfer information over the internet. So you've already seen this, and maybe many of you already know this way better than I do, but you can control your thermostat from your smartphone or your alarm system, which I had an alarm system, I could do that. You can park your car, you can pay for your parking this way, and even your Fitbit is a simple applied version of it, or they probably have an updated version since I had one. And my printer automatically, connected to my new computer. So these are the kind of things that's what the Internet of Things is, that now things that we used to think of as standalone now are connected. So why do we care about that? That means that we can gather data that we wouldn't normally have access to. So with that data, then you can make, things better. So industrials are obsessed about the process, or in the video, Ashley talked about, we don't create a sort of hands-on product, but it's kind of invisible, and oftentimes it's not because it's theoretical purely all the time, it's because it's a process, or we deliver a product, but it's often a process, or a change in the process. So two things I see that are new-ish, or new to many of us, most of us. A lot more data coming at us, and coming at us from different ways. So now it's easy to collect data, and we have these Internet of Things. And the second thing is, what do you do with the data? So now we can, since we have more of it, we can also, it's kind of a different thing. We have more data, but we can also use different tools to deal with that data. Some tools are the same. So when people talk about big data and machine learning and artificial intelligence, I think some people classify regression as artificial intelligence. So don't be too mystified by some of these things. I hope to demystify some of that in your summer semester for folks either starting this May or next May. So in classification algorithms here I have written down, it's saying one of the classic was, if you know the width and the length of a flower petal then you can tell what kind of flower it is, or at least for irises there's 3 anyway. So it's a classic data set, but it's what an interesting idea that you can classify something based upon some data. So that's or you can hopefully classify if somebody's at risk of from a healthcare perspective, are they at risk of passing away from getting this virus, depending on how old they are and so on. So this is so for IE, so maybe it's using the Internet of Things. We can keep track of inventory in a different way than we ever could, because these sensors are cheaper, especially if your inventory is expensive. If we talk about manufacturing, from the algorithm point of view, we can also feed things in. So by machine learning with a classification algorithm, we don't say if this then that, if this then that, like you do. You will learn how to program like that, but machine learning is about using some tools that sort of take care of that themselves. They don't do if then, but they look at the data and use mass amounts of data to make those decisions. Okay, so and I also saw a case study about people who improved the transit route using cell phones, people who volunteered to have their cell phones tracked when they got on and when they got off, rather than somebody sitting in front and checking on how many people coming in the bus and when do they leave and stuff like this. So anyway, so the point is there's new ways of gaining data and new ways of using data, and I think that's those are some two key pieces to to how IE is going to change or how we want to be aware of these tools so we can do our jobs better. Thanks. That's my 2 minutes.
Okay, right. Thanks, Scott. So next we move to just a brief description from Asad on how IE will impact your future career.
Thank you, Dr. Cyrus. So one of the things that we usually hear from people, and they're like, hey, the robots are getting better and better. And with the amount of data that is being collected, there will come a day when they will take over and wipe all of the jobs. Well, no. The robots themselves are able to improve the productivity through their ability to perform repetitive tasks for hours. However, the human input is still required to keep the things running. So what will happen possibly down the line is that the humans will interact with the robots themselves. Industrial engineers, for instance, are the people that analyze the data, the mass amounts of data that is being captured every day, and they will use that to program the robots that we would be having in the future. And as a result, down the line, they would also be the ones perfecting the robots and improving their processes further. Now, moving on to the next slide, we're living in a world where the advancement of technology and the prevalence of the automation and accessibility of technical information it keeps on increasing, right? And that information is being used to just revolutionize or completely change the landscape of industrial engineers, of how they operate. However, one thing that we need to remember is that the basics of how the industrial engineers think and how they approach problems, it will always remain the same, no matter what happens. We will still continue on using Lean Six Sigma. We'll still keep on using the different things that we learn about, the statistical approaches, the amounts of the ways that we analyze the data. However, we will be using different tools. So one thing to remember is that we are in the midst of a new world, but there will always be a demand for human thinking at the center of efficient operations. So the question is, how will you adapt as a student, as an engineer? Thank you.
Okay, thanks, Asad. So now I'll hand you over to Dr. Gassami, who will talk to you about what industrial engineers study and the paths you can take into through the program.
Okay. Thank you, Dr. Cyrus. Okay, so now that you have learned a little bit about industrial engineering in general, what they do, which places they can work, and what type of work they can do, I would like to show you a summary or an overview of the program in industrial engineering. The first thing that I would like to remind you, if you would like to apply for industrial engineering program in Dalhousie, you will need 2 courses to be taken in your lower division, which is data structures and also modeling and optimization for engineers. So you need those 2 courses before you apply for industrial engineering. If you don't have them, you may delay your program for 1 year. There can be other electives between your courses. Next slide, please. So as soon as you join the industrial engineering department, there are 5 distinct terms that you have to go through, and each term has its defined courses. As you can see, we identify terms by term 5, 6, 7, 8, and 9 because you have already passed the 4 first terms in the lower division or in AUs. The order that you will go through these terms is not always to the same order, depending whether you are in a co-op program or you are in a non-co-op program. You may do the terms in a slightly different order, which I will be talking about them later. But no matter what, the first 3 terms that you do in industrial engineering will look like these 3 blocks that you have here. The courses that you go through are, as you heard throughout the presentation, courses about improvement of processes and systems. You will be learning computer methods and algorithms, operational research and linear programming, information management system, and a lot of courses in data management and analysis will come in term 6. And also you will learn about other tools and the skills that industrial engineers will learn, including simulation, quality control, and design of facilities. Next slide, please. The last year of your study will be terms 8 and 9 in the same order. As you can see, you will have to take 3 elective courses, 1 in the 8th term and 2 in the 9th term. And these 2 terms also are the terms that you will take your PII project or project in industry, in which you will be tackling a real-world problem, normally in one of the industries in Nova Scotia or anywhere else in Canada. And you will be engaged in that project for 2 terms, 8 months, and at the end you will deliver them a solution to the problem that they will be using. Now, next slide, please. The courses that we offer you for elective, there are so many courses that you have choice to select in between, depending on your interest, and which you can see many of them, the most common of them on the screen. They may change year by year. You are not limited to these courses. You can also take technical elective courses from other departments and faculties, but they have to go through a approval process. Next slide, please. Now, as I said, depending on what program you enter, whether co-op or non-co-op, there are 3 possibilities for you to go through all these 5 terms. The most general one, the default one, is the one that you see on the right on top. Basically, you start on term 5, and then after each term, you will have 1 co-op term. After doing your 3rd co-op term, there will be 2 terms of term 8 and 9, as I explained a few minutes ago. You can follow the same exact program if you are not in co-op, or whether you are not eligible or you decide not to do the co-op, but instead of all the terms that are co-op, you will have a term off. In that term off, you can use the time for self-development or to work or anything else, but you won't be having any terms or courses in that house. And finally, the accelerated program that you can take, which is the last one shown in the bottom, is in that one you have to start your term 6 in the summer of the 2nd year. So basically, as soon as you finish your lower division courses in May, you start your term 6, and then in the following fall you will do term 5, 7, and then you will have 1 term off, and then finally your last year. So putting all together, you will be able to finish industrial engineering without co-op if you start in the summer in 2 years, or if you are in co-op or decide to take the regular program length, then you will finish in almost 3 years. I think that's all I have. Thank you.
Okay, thank you. So I'll just take you very quickly through the idea of some, so who are some of the prominent industrial engineers? Goes all the way back to, well, actually before Henry Ford, but Henry Ford has really revolutionized manufacturing, especially automobile manufacturing. For example, he cut assembly time for the Ford Model T from 12 hours to 2.5 hours. That's classic industrial engineering. Lillian Gilbreth was a pioneer of industrial management techniques. She was looking at the human side of industrial engineering and developed lots of different ideas about wrong job standardization, job simplification, the effect of stress and fatigue on productivity. Taiichi Ohno was a Toyota executive, and he invented what's called a Toyota production system, which is a forerunner of lean manufacturing. And he also developed what's referred to now as just-in-time systems, where you have essentially zero inventory. Recent industrial engineer, Tim Cook, who is currently the CEO of Apple, specialist in supply chain. He reduced the number of OEM suppliers to Apple from 100 down to 24. And he cut the build time for an Apple computer from 4 months to 2 months. And those are the kinds of things that industrial engineers do. Here's some of our contact information. Generally, you want to contact us, email ing@dal.ca, and we the email will be sent to the appropriate person. At this point, this is where we pause to allow you to ask us any questions you like. So we'll open the floor for any questions anyone has right now. So lots of people here. So we have faculty here, we have students here. What do you want to know? Like you
Hi,
can do
Dr.
a hand
Cyrus.
raise, or you can just speak up.
Yeah, Dr. Cyrus, this is Karen. I was just going to say, I know a lot about the culture of industrial engineering, and I know you did touch on it about a great community. Did you want to talk about some of the opportunities for conferences and student society membership in industrial engineering? Some of the awards, maybe?
Yeah, I think you are involved with the ISC chapter, are you?
Yes, I am.
Yeah.
So currently we have a Institute of Industrials and Systems Engineering chapter at Dalhousie, which basically connects all the industrial engineers together on a network, and this organization basically tries to network as many industrial engineers and system engineers that are out there. So ISE tends to have conferences annually, but due to the global pandemic, we have not been able to go to the conferences lately. There was one conference that was scheduled in Ryerson University probably at the start of this year, but it was canceled because of the pandemic. So yes, we do have conferences that the industrial engineer students attend, and we usually collaborate with the Industrial Engineering Society at DAL to basically go to attend different types of conferences.
Okay, thank you, sir. So as it said before, if you have any questions at all, don't hesitate. Just email us ian@jadal.ca, and the question will be sent to the right person. And anytime you have any doubts at all about anything or any questions about anything, just email us, and the question will be forwarded. Anyone has any sort of final thoughts? Well, one thing I'd just like to say about industrial engineering is that as you probably saw from our presentation and from everyone speaking here, industrial engineering tends to be everywhere. Okay, we're in healthcare, we're in manufacturing, we're in transportation, we're in environmental issues, sustainability, supply chain. It's practically, you name it, and there's an industrial engineer somewhere. I personally have students that I taught who work at Air Canada, CN Rail, Air Nova. They work at all of the manufacturing companies around here. We've had people working with Warner Brothers, with Airbus, with Boeing, with Apple. It just keeps going on. If we put all of the logos on one screen, it actually doesn't fit. We had one of those screens at one time, and there'd be logos everywhere, and you couldn't even read the thing because there were so many of them. But essentially everywhere, you name an industry or name any sort of enterprise, and there are industrial engineers there somewhere. And so there's a place for everyone.
Perfect. Well, thanks, Dr. Cyrus, and everyone who presented today. We really appreciate all the information. That was really interesting. And thanks for everyone who showed up to participate.